Today I'll be showing you how to write an equation of a line by looking at the graph of that line. So we've learned that linear equations are frequently written in slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. So in the previous objective, we looked at an equation in slope-intercept form and drew the graph. Now we're going to look at the graph and write the equation. So we're just reversing that process. We're going to look at these equations and identify the slope and the y-intercept and then plug it into the equation y equals mx plus b. So I just want to remind you about slope. If I have a line that slants upward from left to right, this is a positive slope. And if I have a line that slants downwards from left to right, that is a negative slope. So let's look at example number 1. We need to find m, the slope. So let's look at the line that's plotted on the graph. And the first thing I'm going to do is look to see if there are points closer together than the ones that are plotted. And right now I can see that there is a point here that's a little bit closer that I can use to draw my slope. So remember, you're just going to make a triangle. And here we have 3 and 2. So remember that our slope is rise over run. So my slope is going to be 3 over 2. Now I need to look, is this a positive slope or a negative slope? A negative slope slants downwards from left to right, so this is going to be a negative slope. So my slope is negative 3 over 2. Now to find the y-intercept. The y-intercept is the point where the line crosses the y-axis, which is this point here. So 1, 2, 3, 4, 5, 6, 7. B is positive 7. Now that I have my m and b, I can plug it into the equation y equals mx plus b. So I have y equals negative 3 over 2 x plus 7. Number 2. Here's my line. I'm going to look for a point that might be closer together. You can use the points that are plotted here, but you may end up having to simplify the fraction. So I would rather find 2 points that are closer together, and I can see that there's a point right here that I can use. So my little triangle here, 1 and 1. So my slope is 1 over 1 or just 1. And because it slants upwards from left to right, this is a positive slope. My y-intercept, where the line, oh, I'm actually writing this on the wrong line. This goes up here. The point where the graph crosses the y-axis is here. And this is 1, 2, 3, 4, 5, negative 6 on the y-axis. So my equation will be y equals 1x minus 6. Now, usually you will not see the 1. It's going to just be x minus 6. But when you have an equation, y equals x minus 6, you know that the slope is 1. Let me just show you here that I could have used this entire triangle with the 2 dots that are already plotted there, but this would have been 5 over 5, which simplifies to 1. So you still can use the points that are farther apart, but you will not have a simplified fraction, and so your equation won't be fully correct because you do have to have a simplified fraction. Number 3. The 2 points that are plotted there look to be the closest ones. I don't see any other cardinal point that I can use, so I have 4 and 3. So my slope is 4 over 3. This is a positive slope. And the y-intercept is here at the origin, so my y-intercept is 0. My equation will be y equals 4 over 3x plus 0. Now, I will never see that in an equation. You'll never see plus 0. So it's just 4 over 3x. Number 4. Let's see if there's any points closer together. I do see a cardinal point right here. So I will use this triangle, 1, 2, 3, 4, 5, and 1. So rise over run, 5 over 1. This slants downwards, so this is a negative slope. Anytime I have a number over 1, I'm just going to use the whole number as m. And this crosses the y-axis here. So 1, 2, 3, 4, 5, 6, 7, 8, positive 8. So my equation is y equals negative 5x plus 8. So this is what you'll be doing in today's practice.